Hello everyone, how's it going? My name is Dan the Tutor. This is going to be lesson 7 of the Algebra 2 summer course. Today we're going to be talking about asymptotes. Maybe you've heard of an asymptote before, maybe you have not. Regardless, I'm going to be explaining what they are, how you find them, and it's funny because this is something that you first learn in Algebra 2, you probably learn it again in pre-calc, and then by the time you get to calculus, you're going to learn about something called limits at infinity. And you're going to say, hey, that sounds a lot like a horizontal asymptote. So that's just a little, foreshadowing for you for 2 years from now. Kind of 3 years from now because you haven't even taken Algebra 2 yet. But it's coming one day. And you can say, hey, Dan the Tutor said that 3 years ago. And I'll be like, yes, I did. And why are you contacting me? So first let's start off with what is an asymptote. An asymptote, I do not have it on this graph right here. We're going to be drawing it. But an asymptote is a dotted line that the function approaches but never touches. So for instance, where are the asymptotes on this line? I'm going to draw them in blue so you can see them. They are right down the middle on both axes for this graph specifically. This is the graph y equals 1 over x. And by the end of today, you'll be able to tell me where those asymptotes are. But just look at this graph. Notice how the red line will come close to, but it will never touch the blue dotted lines I just drew. As a matter of fact, if you want to plug in values to see what you get, you can plug in a value super close to 0, like x equals 0.0001. If you plug in x equals 0.0001, you'll get y equals 1 divided by 0.0001, because that's what 1 over x is, if you plug in that for x. And so the y value you get, you plug that in a calculator, you'll get 1,000. So in other words, when you get super close, it doesn't touch it, it's just getting bigger and bigger and bigger. Like if I had graph paper that went up to 1,000 grid marks, which would be pretty impressive, then I could actually plot this. So instead of getting super big graph paper, instead we draw the asymptotes to signify that the graph is getting close to but never touches that value. And I think we all know why it never touches the 0 line. It's because you can't have a 0 in the denominator. Like if I plug in 0, I get 1 over 0, and we say that's undefined. What does undefined look like on a graph? It looks like a it's called a vertical asymptote. We don't know vertical versus horizontal yet, but we'll just call it an asymptote for now. And then on the next page, we'll make the difference between horizontal and vertical asymptotes. And by the way, you can say the same thing on the right side. Like you're getting closer and closer and closer to that 0. As a matter of fact, if I plug in a number like x equals 1 million, well then what would the y value be? Does it cross yet? Does it get to 0? Well, it would be y equals 1 divided by 1 million. And in case you're wondering what that is, it's 0.000001. And I'm not kidding, that's the exact number of zeros. Is that 0? No, it's extremely close to 0, but it never actually touches 0. Any questions on what an asymptote is? Okay, so now we're going to talk about, for the next about 5 minutes, we're going to talk about how to draw asymptotes. So first, I do not want you to graph the function y equals 3. I want you to graph the asymptote y equals 3. What's the difference? Remember, asymptotes are dotted lines, so first of all, it has to be a dotted line. And second of all, since it's y equals, it is going to be horizontal. So it is a horizontal line at 3, and it's dotted. So in other words, it looks like this. And there you go, you just drew the asymptote. Obviously, it looks a lot more interesting if you have a function, because here's some functions that it could look like. For instance, it could look like that, where it's almost touching 0 from one side. You could even have it look like this in blue, where it's touching that side. The side doesn't matter, but it's approaching one of the sides, that's for sure. Technically, you could even approach both sides if you really wanted to. Okay, so that's that first one. Now, for the next example, x equals 1 and y equals 4. So remember, x equals is a vertical line, y equals is a horizontal line. So when I do x equals 1, that's just going to be a vertical line at x equals 1. That's x equals 1. And then y equals 4, that's going to be a horizontal line at 4. 1, 2, 3, 4, right there. So there we go, there's the asymptotes for this one. And again, the graph could look like anything as long as it doesn't cross those lines. Now for number 3, with those 3 asymptotes, go ahead and try it yourself. I'll give you about 30 seconds to do that. If you're watching the recording, just pause the video. And time's up. It's okay if you didn't finish. So first, I'll do x equals -3 and x equals 5. That's going to be vertical because they're x equals. So here's -3, vertical line there. And then at 5, 1, 2, 3, 4, 5 should be right there. And then for y equals 0, I mean the y equals 0 and x equals 0 is always hard to see because it's on the axis. So make sure you draw those especially bold so you can actually see it, especially if you're writing in pencil. And that's what it should look like for the asymptotes. Any questions? Now here's a fun fact. I'm just going to tell you this. You don't have to write this down. Technically, you can have as many vertical asymptotes as you want. It doesn't matter. You can have 1, 2, 3, 0, any number of vertical asymptotes you want. For horizontal asymptotes, generally speaking, you're only ever going to see one horizontal asymptote on a graph. And there's a reason for that. It's not worth explaining right now. But instead, let's focus on how to find these asymptotes. So first, let's talk about vertical asymptotes. Remember the up and down ones. All you have to do is set the denominator equal to 0 and solve. And this makes sense because of what we said earlier. What did we say earlier? We said that the vertical asymptote is where the denominator is 0. So if you set the denominator equal to 0 and solve, well, that's how you get your vertical asymptotes. So for instance, here, if I want to find the vertical asymptote for this function, I just do x minus 8 equals 0, add 8 to both sides, you get x equals 8. Simple. Now for a harder one, you have x plus 4 over x squared minus x minus 2. Do I care about the numerator at all? Not really. All I care about is setting the denominator equal to 0 and solving. And I'll admit this one's harder because you got a factor, but even factoring it's not that hard. This is just going to be x minus 2 times x plus 1 equals 0. And so then I get two answers. I get x equals 2 and -1. Now don't write your answer like this. When you write your vertical asymptotes, you got to write it as two different lines like this. And I am going to make a big deal about it. Not that it's that important, but I'm always a stickler for good notation, and why would I write the wrong answer anyway? So with that in mind, I think we're ready to go on to horizontal asymptotes. I will say, I'm warning you now, there is one more thing about vertical asymptotes that I'm going to say like towards the end of the lesson that makes them harder than they appear. But for now, this is perfectly fine. This is a good definition. But we're just going to deal with that definition for now. Okay, so now with the horizontal asymptotes, you can have one of 3 different cases. To look at horizontal asymptotes, all you got to do is look at the degree of the numerator and the degree of the denominator. When I say degree, I'm talking about the x cubed here and the x squared here. I don't care about anything else. Like the -1, the 4x plus 8, I don't care about that at all. So then what do I say here? This is case 1 where your degree of the numerator is greater than your degree of the denominator. And when that happens, there is no horizontal asymptote. There is no horizontal asymptote. By the way, it's for this reason you're never going to see a horizontal asymptote or a vertical asymptote for a linear line, for a parabola. Basically, if you want to have asymptotes, you need to have a denominator. And the denominator needs to be of sufficient size. And when I say sufficient size, well, let's look at case 2. For case 2, we say the degree of the denominator is... Oh, sorry, I said it backwards. Degree of numerator is less than the degree of the denominator. Same thing. So basically here you look at the x in the numerator and the x squared in the denominator. In this case, the denominator degree is greater than the numerator degree. And when that happens, the answer is you have a horizontal asymptote, which I'm going to abbreviate HA. You've got an HA at y equals 0. It will always be 0 when the denominator is higher than the numerator. Always. And then the third and final case, of course, would be if the degrees are equal, as you can see here. So if the degrees are equal, this is the worst case scenario. It's not that bad. It's pretty easy, actually. But this is the hardest case. All you need to do is look at leading coefficients. Look at leading coefficients. What does that mean? It means I'm looking at the 3 in front of the x squared, and I'm looking at the negative 4 in front of the x squared. In other words, if I were to divide these two leading terms, I would say 3x squared over negative 4x squared. The x squareds cancel, and then I get a final answer of negative 3/4. And that's where your horizontal asymptote is at. Y equals negative 3/4. And in the future, you can get that really quickly. As soon as you identify the degrees are equal, you can immediately say negative 3/4. So any questions on any of those? Okay then, now we're going to do some practice. Find all the vertical and horizontal asymptotes. Write your answer in the form of a line. When I say write your answer in the form of a line, I'm just saying write y equals 2 or x equals 0, something along those lines. So for this one, first I'm going to start with the vertical asymptote because it's always easier to start with the vertical asymptote. Remember, vertical asymptotes, how do I find those? You set the denominator equal to 0. So 4x plus 6 equals 0. Subtract 6 from both sides. 4x equals negative 6. And then you'll get x equals negative 6 over 4, which reduces to x equals negative 3/2. And there's our vertical asymptote. Any questions? Okay. So we're not done yet. We still got to find the horizontal asymptote. Remember what we said just a minute ago. Horizontal asymptotes, you're looking at the leading degree. It looks like in this case the degrees are equal. They're both x. And because the degrees are equal, you just look at the coefficients. In other words, 2 over 4, which reduces to 1/2. And so therefore the answer is y equals 1/2. And so there we go. It looks like there's one vertical asymptote and one horizontal asymptote for this problem. Any questions on that one? Okay, great. Next, number 2. Again, I'm going to walk us through it. Number 3, I'll let you try on your own. But for number 2, just one more time, I'm going to help walk you through it. First, if you want to find the vertical asymptotes, what do? I got to say x minus 10 equals 0. I don't even care about the numerator for vertical asymptotes. So I add 10 to both sides, x equals 10, easy peasy. Now the horizontal asymptotes, what am I going to do? Well, hopefully you realize the degree of the numerator, x squared, is greater than the degree of the denominator, x. So I'm saying numerator is greater than denominator. Who remembers what happens in that case? It's going to be no horizontal asymptote. And that's what you would write. You would write no horizontal asymptote. Also, that's a funny word. Like I've been saying it for years, asymptote. It's probably going to take you about a week to really pronounce that correctly. Asymptote. Okay, so assuming there's no questions there, I want you to try number 3 on your own. I'll give you about a minute, maybe a minute and a half to do this. And then, for those of you watching the recording, just pause the video and go ahead. And time's up. So first, for the vertical asymptote, all I need to do is set the denominator equal to 0. Hopefully you remember how to factor this. The factors that I need here are going to be 6 and 8. And it's going to be x plus 8 times x minus 6. That's going to give me the plus 2x in the middle. So then the answers are x equals negative 8 and x equals positive 6. And remember, I'm going to write it out twice because that's what I want to do. Now for the horizontal asymptote, again, I see the degrees are equal, x squared and x squared. So the degrees are equal. And maybe you don't know what to put here because there's no numbers in front. Remember, if there's no numbers in front, there's like an invisible 1 in front of both of those. So the answer is 1 over 1, which is just 1. And as my final answer, I would write y equals 1 because that's the horizontal asymptote. Any questions on number 3? Okay. Now for numbers 4 and 5. And by the way, the original way I had this lesson designed, we're going to end like in about 10 minutes. It's going to be literally the shortest lesson out of all 8 of them. But then I realized like this is so short, and really there's a couple special cases of asymptotes that I want to talk about, especially hidden within number 4. Number 4 is especially devious. But we're going to do that. In the problem, I ask you find the asymptotes and then graph the asymptotes. Notice I don't say graph the functions, I just want you to graph the asymptotes. That's what I'm going to have you do on the homework. But during the lesson today, we're going to go a little advanced, okay? You don't have to do this on the homework, but I'm going to graph the entire function to show you how to do that, because you're going to figure that out either in Algebra 2 or pre-calculus, that's for sure. So with number 4, first thing we're going to do, find the asymptotes. How do I find the vertical asymptote? Well, all I got to do is say 2x squared plus 6x plus 4 equals 0. This one's pretty challenging to factor. Does anyone have any ideas on how to help make it easier? Well, I would say factor out a 2 from the beginning. In other words, divide everything by 2. X squared plus 3x plus 2. And now this is significantly easier to factor. It's going to be x plus 2 times x plus 1. Technically, the 2's still out in front, but that's really not going to matter for this problem. And so I get x equals negative 2, and negative 1 is my 2 answers for the vertical asymptote. And then for the horizontal asymptote, I'm going to do the same thing as before. I see the numerator is 5x, denominator is 2x squared. I say that the denominator is greater than the numerator, obviously, because x squared is greater. And so that means there is no I'm wrong. Sorry. It's not no horizontal asymptote. It's y equals 0. That was a test. Yes. So y equals 0 and x equals negative 2 and negative 1 are my vertical asymptotes. And now if I actually want to graph this, first I'll graph the actual asymptotes. And this is what I do want you to write on your paper. So here's negative 2 right there. Here's negative 1, very close together, I will admit. And then y equals 0, which is like on the line, the x-axis. Make that especially bold so you can see it. So originally this is all I want you to do, and this is what I want you to do on the homework. But now if you want to actually graph this, I recommend making a table of values. And if you want to know how to graph this, you want to choose a point. Let's just choose some x points. I'm going to choose negative 3 for the left side, right here. I'm going to choose a point in the middle of this sliver, and the point I'm going to choose is negative 1.5, because that's the only real number between negative 2 and negative 1. Of course, you can do any decimal, it doesn't matter. And then on the right side, anywhere in this region, I'm going to choose x equals 0. Not y equals 0, x equals 0. So I did this earlier. You can just plug this in a calculator. For the first one, you get negative 1.25. For negative 1.5, you get negative 5. And for 0, you're going to get 2.5. Now let me graph these points on the graph. Here's negative 3, negative 1.25, right about there. Here's negative 1.5, negative 5. 1, 2, 3, 4, 5, right here. And here's 0, 2.5, right here. And before I graph these lines, I just want to tell you something really weird that happens. And it's such a coincidence that, like, I don't remember making this. It was like so many months ago, this lesson. But there is something that happens here that is like so much of a coincidence, I almost think it was intentional when I made this like a few months ago. And that is the fact that negative 2 is actually not a vertical asymptote. What do you mean? Let me explain. So first, let me just write out this again. 5x plus 10 over 2x squared plus 6x plus 4. By the way, everything I'm about to tell you does not matter for the homework, but it does matter at some point in your math career. Probably Algebra 2, definitely pre-calc. It's going to show up. But here's what I'm going to say. We factored the denominator. Remember the denominator, we got 2 times x plus 2 times x plus 1. As it turns out, you can also factor the numerator. Normally you can't factor the numerator, but in this case you can. If you factor out a 5, then you get x plus 2, and look at that, the x plus 2's cancel. So really you're left with 5 over 2 times x plus 1. And for that reason, the only vertical asymptote is technically -1. Now again, this is a very special case. I don't even know if this was intentional or not. But there's still a problem, because if I plug in -2, like right now, if I plug in -2 in the numerator and the denominator, what do I get? I don't get 1 over 0. I get 0 over 0. And do you know what 0 over 0 is called? It's not called undefined anymore. 0 over 0 is a very special case. It's actually called indeterminate. You don't need to know this word, but I'm just writing it down so you know. And it is actually the basis for calculus. As a matter of fact, the whole reason why we have calculus as its own math course, and it has like, all those special names, it's for this reason right here. Everything you do in calculus one day is going to have to do with this fact that 0 over 0 is called indeterminate and it's no longer undefined. So what does that mean to you? What does that mean about asymptotes? It means it's not an asymptote, it's actually a hole in the graph. It's going to be a hole in the graph. Well, what does that look like? I'll tell you. So basically, let me erase the asymptote at -2 because it's not actually there. I want you to keep it on your paper just so, you have it. But what it actually looks like is something like this. Notice the dot I just drew is open as opposed to a closed circle. Very similar to inequalities, it's an open circle. And basically what the open circle means is that the function exists everywhere except -2. Like if I were to actually graph this, and now I'm going to show you how to graph it. To graph this function, all you got to do is connect the dots and then draw your line close to but not touching the asymptote. So in other words, draw it like this and then never let it touch, but let it get really, really, really close. And then going the other way, again, approach but never touch that asymptote. And then on the other side, you're going to do the same thing. Literally, you just need 1 point to graph this side. And let me show you why you only need 1 point. Let me just show you what a wrong answer would look like, okay? A wrong answer would look like that. And the reason why that's wrong for that line is because you cross 2 horizontal, or 2 asymptotes. It can't look like this for the same exact reason. You've got to bend it. So you've got to bend it. By the way, this is wrong. You can't do that because if you just extend the line more, you're going to hit that asymptote right there. You can't do that. So the only way you can graph this is starting from the dot and approaching the asymptotes on each side. That's how you graph functions. You literally just plug in a table of values and curve the function around the asymptotes. And if you plug this in your calculator, in a graphing calculator, you're going to get this exact answer. Although the graphing calculator isn't really a good job of graphing the open circles. Like it's not going to see that open circle right there, basically, because the calculator, what's it called, the pixels are literally too small to see that open circle. But theoretically, this is what the graph should look like. Now, do I expect you to know this? No, I just expect you to know how to find vertical and horizontal asymptotes. And even that thing I just said about canceling out with the hole in the graph, you don't even have to know that. This is a summer course. I don't want you to be stressing out over that kind of stuff. That's super advanced. Honestly, I didn't even know that until pre-calc, not Algebra 2. So you're going to be fine. Anyways, for the last one, I'm going to tell you just right now, there's no holes in the graph. You're not going to factor this numerator. This is way too hard to factor. So let's just focus on the vertical asymptotes and horizontal asymptotes like normal. Remember, for vertical asymptotes, I'm just setting the denominator equal to 0. And how am I going to solve this? Well, there's a couple things you can do. One is you can first factor out the -3, but I'm going to do something different slightly. It doesn't matter. You can factor out the -3. It's not wrong. But first, I'm going to subtract 12 from both sides. So -3x squared equals -12. Then I'm going to divide both sides by -3. So I get x squared equals +4. And then I'm going to take the square root. But when I take the square root, what's the one thing that you have to remember that all my students forget? Plus or minus. So in other words, x equals plus or minus 2. Again, I'm going to write that as a line. X equals 2, comma, x equals -2. That's how I'm going to write it. And then for the horizontal asymptotes, again, I got to look at the leading degree. It looks like I have -9x squared and -3x squared. those degrees are equal. Degrees are equal. So you just divide the two numbers. -9 over -3 equals +3. So the horizontal asymptote is at y equals 3 for horizontal. And this one I'm just going to graph just like normal. First one at -2, then one at +2, and then one at y equals 3. So there's my asymptotes. Now again, if I want to plot these, if I actually want to graph these, which I am going to, I need to make a table of values here. So if this is -2, this is +2 for the x, I'm going to choose the following points. To me, this makes the most sense. For my x values, I'm going to choose -3, -1, 0, 1. I'm going to skip 2 because that's the asymptote, and I'm going to end on +3. And again, you can plug these in a calculator because it's a lot to do, and I did this earlier today. So the y values are 5.1, 0.4, 1.4, 1.3, and 3.5. Obviously, decimals aren't the most friendly thing, but at least we know how to graph these. And so now if I were to plot these points on the graph, I will do that now. Well, first let me just put it back here. Hopefully everyone had time to write this. I'm assuming you did. Anyways, so we've got first -3, 5.1. 1, 2, 3, 4, 5, and then 5.1 is just a tiny bit more. Next, -1, comma, 0.4. Here's -1, 0.4 is right about there. Next is 0, 1.4. That's right about here. Then you got 1, comma, 1.3, which is just going to be a tiny bit lower. Barely noticeable. Skip 2, and then 3 is 3.5. 1, 2, 3.5, right there. Just above the asymptote. And now this is all I need to graph everything here. Like, for instance, the left side, I start from the dot and I go towards my asymptotes. Towards the asymptotes. Next, for the middle one, this is interesting. I'm going to basically start here and just go down like that. And then same thing on the other side. I kind of missed that dot, but you get the picture. And then for the last one, again, just follow the dots and go towards the asymptotes like that. And it's going to look like an L shape. And again, if you plug this in your calculator, this is going to be the right answer. Now, here's the last thing I'm going to say, because we're done the lesson, but I just want to end on this very fun fact. And this is going to make you hate me. And I can live with that, because at least what I'm saying is not false. I'm not going to lie to you, but I am going to make you hate me. Is it possible to cross a vertical asymptote? The answer is no. In other words, let's just say I have a graph. Whoops. Let's just say I have a graph that looks like this, and I've got a vertical asymptote right here. You will never, ever have the function pass a vertical asymptote. It's impossible. That's illegal. But is it possible for a function to pass a horizontal asymptote? The answer is sometimes. And this is the annoying answer. So again, here's an example. This one I'm going to give 2 vertical asymptotes and a horizontal asymptote. You don't have to draw this if you don't want to. But I do want to tell you it's possible to have this as your graph. That shape there, this shape in the middle, and then this shape over here. This is possible. And the reason why it's possible, by the way, is because the horizontal asymptote does not work for the middle. What do I mean it doesn't work for the middle? I'm saying for this point right here, see how it's in the middle of the 2 vertical asymptotes? The graph doesn't have to follow it there. The horizontal asymptote only has to go with the graph at the ends, on the left side and on the right side. And the reason for that is because, well, that's just how horizontal asymptotes work. The technical answer will involve calculus, which we're just not ready for yet. But it is possible to cross a horizontal asymptote in the middle only, and a vertical asymptote you will never cross. So with that, I'm going to end the lesson for today. Make sure you do the homework. And then next week, we're going to have the very last lesson, lesson 8. Stay tuned for that. Thank you all for attending, and I'll see you next week. Bye-bye.